make sure. Okay, we can start by looking at number 11. Okay, this is how I want you guys to think about this. I want you to think about, we want to write everything in terms of sine and cosine, okay? So we want only sines and cosines. Think of it like that, okay? The only time we do anything different, if it's clearly, like on number 13, do you see how it's clearly in a Pythagorean identity? So if we went to our identities here, okay, we see cosecant squared minus cotangent squared. If we look right here, we know we're going to use this one, cosecant squared, and we want to make this look like cosecant squared of theta minus cotangent squared of theta. To do that, we would just subtract cotangent squared of theta minus cotangent squared of theta, and we can transform this identity into another one that matches, which is 1 is equal to cosecant squared of theta minus cotangent squared of theta. So that means, like right here on problem 13, this is just what number? This is just the number 1. Do you see that? Now if you look at the bottom, 1 minus sine squared of theta, we could subtract sine squared of theta here, and that gives us cosine squared of theta is equal to 1 minus sine squared of theta. Well, look, we have sine squared of theta here, so what can we replace it with? What can we replace 1 minus sine squared of theta with? Alexia, what can we replace 1 minus sine squared of theta with? Do you see how we just solved this? So what can I replace 1 minus sine squared of theta with? Okay, do you see how this says 1? Do you see right here, this says 1 minus sine squared of theta, right? What is it equal to? What is it equal to? It's equal to cosine squared of theta. Do you see how we found that? So over here, we can replace this with cosine squared of theta. So then we would just be left with 1 over cosine squared of theta. And we know that cosine squared of theta is just, 1 divided by cosine squared of theta is just equal to what? 1 over cosine of theta is secant of theta. So 1 over cosine squared of theta is equal to secant squared of theta. And guess what? That's what we wanted to find. Are there any questions? This was an example of when we use our identities, okay? Unless we're clearly using our identities and it looks like one of our 3 main Pythagorean identities, we are just going to want to break up everything into sine or cosine. Now, let's go to problem number 11 from the homework, okay? I would ask that you all please try to pay attention, okay? So that means look at the board. Please, look at the board. All of us? Each and every one of you? Okay. So, cosine, we're going to leave that as cosine, right? We don't want to touch cosine. How can we rewrite cotangent? Yes, go ahead, Alvin. Very good. So we have cosine of theta times cosine of theta divided by the sine of theta. Plus, do we want to change sine of theta? No, we do not. So we're going to leave that as sine of theta. Okay? We're going to simplify this further by multiplying these, and that gives us cosine squared of theta over sine of theta plus sine of theta. All right, this is the hard part. This is the part where you make mistakes, and that's okay, but let me help you. You have to ask yourself, where do I go from here? Okay? It's trial and error, it's hard, and you have to think. All right? You know that you're trying to get this equal to cosecant of theta, right? Which is one term. So we need to try to put those together. Does that make sense? Can you see that? That's really our only option now. Now, how would we put these together? We would need a common denominator, right. And what is that common denominator? Sine of theta. So we need to multiply this guy by what over what? Sine of theta over the sine of theta. This leaves us with cosine squared of theta over the sine of theta plus sine squared of theta over sine of theta. Now we haven't made this just one yet, have we? How can we make this just one? Add the tops and the bottoms stay the same. So this is cosine squared of theta plus sine squared of theta all over sine of theta. At this point, you should automatically know what sine squared of theta plus cosine squared of theta is. And what is it? 1. You need to know that. You need to know that sine squared of theta plus cosine squared of theta is 1. Which means we have 1 over sine of theta. And ladies and gentlemen, what is 1 divided by the sine of theta? The cosecant of theta, which is exactly what we wanted. Okay. Are there any questions about 11? Yes, Alvin.
I mean, not about 11.
You want to go to which one?
15, but so we would need to memorize the formula.
Okay, on 15, Alvin, how can we rewrite the cosecant of theta?
One over the sine.
Very good. This is 1 over the sine of theta. And how can we rewrite the tangent of theta?
Sine of theta over cosine.
Perfect. Now, is there anything that we can simplify here, Alvin?
Oh, yeah. Cancel off the sine of theta.
Good. And what does that leave us with?
Cosine of theta, which is
Very good. That one was not too bad, was it?
no, I just kind of had to think about it.
Okay, good. That one wasn't bad. Yes, sir.
I thought you don't change cosecant or secant.
Yeah, we're going to change everything if it's not sine or cosine. The only times we probably wouldn't want to do that is for our identities like I showed you earlier. Do you remember? Yeah, like number 13. Okay? All right, so let's go and look at number 19.
I'm noticing this is a little bit, like, not too complex, but it's like, we gotta do.
Okay, so let's look at 19. I'm sorry, 19, right, Alvin?
Yeah.
Okay, on 19, I'm going to go ahead and you can do whatever you want to. If you wanted to first rewrite secant as 1 over cosine, you could. Or if you wanted to distribute first, you could. I'm going to go ahead and distribute. So that gives us the cosine of theta times the secant of theta. And then distribute, oh, sorry. All right, so now we're going to distribute cosine of theta to cosine of theta, and that's going to give us minus cosine squared of theta. Okay, now there's only one thing that we really want to change here, and what is that? One thing. What is it? Tiffany, what's the one thing we want to change? Secant. Perfect. And what are we going to change secant into, Patricia? What is secant of theta equal to? Look at your formula sheet. 1 over cosine. So that's what we're going to change it into. So we have cosine of theta times 1 over the cosine of theta minus cosine squared of theta. Okay? Now, Patricia, what is cosine of theta times 1 over the cosine of theta? I'll say that again. What is cosine of theta times 1 over the cosine of theta? All right, time out. All right, look, we are just multiplying what is cosine of theta times 1 over the cosine of theta.
Yeah, I know.
What is that?
Cosine theta over cosine theta. Wait, cosine squared theta.
All right,
There's no square.
right, because we're just,
They cancel out.
all right, well, let's get somewhere before we get there. Cosine of theta times 1 is just cosine of theta. 1 times cosine of theta is cosine of theta. So then minus the cosine of squared of theta equals, what is cosine of theta divided by cosine of theta, Patricia? 1. So now we have 1 minus cosine squared of theta. Now when you see this, you need to be able to recognize this as a Pythagorean identity. You need to know that it looks something like one of those three somethings, okay? And you need to go back to your little green sheet, which again, you will not have in your test. You have to have this memorized. You'll go back to your little sheet, and you will say, oh, which one of these guys is it going to be? We want 1 minus cosine squared, right? Excuse me?
How do you get it from 1 minus cosine?
Well, we have sine squared plus cosine squared equals 1, right? So if we subtracted cosine squared, then we'd get sine squared of theta equals 1 minus cosine squared of theta, correct? Do you see that? If we subtract cosine squared from both sides, we get sine squared of theta equals 1 minus cosine squared of theta, correct? Yes? So, what is this just equal to?
Sine squared.
And guess what we wanted it to be equal to?
Sine squared of theta.
Sine squared of theta. So we have verified this identity. It's not a lot to memorize, and let me tell you why. It's not a lot to memorize because you already knew that the sine of theta is the sine over cosine. I'm sorry, you already knew tan of theta is the sine over cosine. You knew that tan of theta is equal to y over x. And you know that sine is y, cosine is x. You already knew that the cotangent is x over y or cosine over sine. You already knew that the secant of theta is 1 over cosine. So if the secant is the reciprocal of cosine, then the cosine is the reciprocal of secant. If the cosecant is the reciprocal of sine, then sine is the reciprocal of cosecant. And if cotangent is the reciprocal of tangent, then tangent is the reciprocal of cotangent. The only thing that you're learning are these three things. As long as you know this is sine squared plus cosine squared equals 1, then you can derive these other two just like I showed you in class yesterday. It is not that much to learn. The only new things you are learning, honestly, are 1, 2, and 3. And if you feel like it's that much, then you need to spend more time studying, okay?
Is there tests?
What we're going to do now is I'm going to hand you out the notes that we will be taking today. Excuse me. Could you please not speak? Thank you. Sure. Yes, I am. Excuse me. Please stay quiet. I got it. Please raise your hand if you did not get a copy of the Trig Identities Day 2. Excuse me. Please raise your hand. Excuse me. Please raise your hand if you did not get a copy of Trig Identities Day 2. Okay. Meg, did you pass them back? Okay, so let's continue. I am. All right, so on number 1, what I need for you guys to look at is I want you to look and see that on number 1, this is going to have something to do with one of our trig identities, okay? And which one do you think that's going to be? Right, tan squared. We know that the tangent squared of theta plus 1 is equal to secant squared of theta. Okay? We need 1 minus secant squared of theta, which means we need to move the secant squared of theta over. But then that gives us tangent of theta, tangent squared of theta, plus 1 minus secant squared of theta equals 0. And we need to move that tan of theta, tan squared of theta over, so minus tan squared of theta minus tan squared of theta, and that gives us 1 minus secant squared of theta equals negative tan squared of theta. Okay? Which just means that our answer is negative tan squared of theta. The only difference between what we did before and what we're doing now is we're just trying to write it in as simple forms as possible. We're not trying to confirm that it's equal to something. We're just trying to simplify it. It's like the difference between an equation and an expression. We're just simplifying an expression here. That's a negative tan. All we did is we rearranged one of the Pythagorean identities. That's all we did is rearrange the equation. Okay? All right, so let's look at example number 2. We need to rewrite cosecant. How can I rewrite cosecant, Sam? How can I rewrite the cosecant of theta?
The cosecant?
Mm-hmm. 1 over the sine of theta. And how can I rewrite the tangent of theta, Sam?
Sine theta,
All right, now can I simplify this with?
1 over cosine theta.
Is this as simple as it can get, Sam?
Yes. No. Yes.
This is equal to the secant of theta. Are there any questions?
Is that it?
That's it. Okay, when you look at example number 3, does anything come to your mind, Sierra? Pythagorean identity, right? And you said the third Pythagorean identity? The third Pythagorean identity states that 1 plus the cotangent squared of theta is equal to the cosecant squared of theta, which means we want to rearrange this so we get the cosecant squared of theta minus cotangent squared of theta. How could we do that? How could we do that, Anaya? How do we rewrite the cosecant squared of theta minus the cotangent? I'm sorry. How do we rewrite 1 plus cotangent squared of theta equals cosecant squared of theta? This identity, how can we rewrite it to match cosecant squared of theta minus cotangent squared of theta? Over here, we're going to want to subtract cotangent squared of theta. So then that gives us 1 equals cosecant squared of theta minus cotangent squared of theta. So what is cosecant squared of theta minus cotangent squared of theta? What does that equal to? What does that equal to, Anaya? What is this equal to? What is it equal to, other than itself? What is cosecant? What is cosecant squared of theta minus cotangent squared of theta equal to? I'm sorry? It's okay. I will find another way. So let's rewrite this. 1 plus cotangent squared of theta equals cosecant squared of theta. Okay? So, Anaya, we want to, how can we rearrange this equation so it looks like this? We subtracted cotangent squared of theta from both sides. And that left us with 1 is equal to cosecant squared of theta minus cotangent squared of theta. My question to you was, what is cosecant squared of theta minus cotangent squared of theta equal to? It's equal to 1. Thank you. It is equal to 1. Okay? Do you guys see how we can rearrange these trig identities to find out what they're equal to? Do you understand that? Like we just did? Okay? Please look at example number 4. On number 4, how could we rewrite the tangent of theta, Hiram? How do we rewrite the tangent of theta, Hiram? Do you remember me asking you to put those those big stars? Remember, every time we want to write in sine of theta divided by cosine of theta. Thank you. And Hiram, how can I rewrite the cotangent of theta? Very good. Now, Hiram, do I have anything that I can simplify here? What? Cross out what? Cosine and sine, and we just get 1, right? Are there any questions? Yes?
How do you know to use quotient identities?
Because, well, we've talked about it a few times yesterday. In addition, if you guys need to pick up your, hold on 1 second. Okay, sorry. You said, okay, so yesterday, who was I talking to? Patricia? Yesterday we talked several times about quotient identities were super important. Today I was very specific about us wanting, unless there's a Pythagorean identity clearly established from the beginning, we want to write everything in terms of sine and cosine. So if we replaced cotangent with 1 over tan, that's not sine or cosine, so that's not what we want to do.
So all of these on here will be sine and cosine.
Unless we can just immediately identify them as a Pythagorean identity, yes.
How will you know?
Okay. How will we know if it's going to be a Pythagorean identity? Like if you look at number 1, do you see?
I keep looking at the reciprocal identities.
Reciprocal identities are important, and you should have already known those, and you do still need to know those.
No, I know them, but like, why are they here if we're not going to use them?
We do use them a lot. Okay? For example, if we had the cosecant right here, number 6, secant of theta, we need that reciprocal identity to write that in terms of cosine, to write this as 1 over the cosine of theta. Do you understand how we just use that reciprocal identity there?
I mean, like, I get how you used it, but why wouldn't you use it
On number 4?
Yeah.
Well, on number 4, we want to write it in terms of sine and cosine, and we can't do that using the reciprocal identity. If on number 4 you want to write this as 1 over the cotangent times 1 over the tangent, right? Like, is that helping us do anything? Are you feeling like we can simplify this any further?
Yeah, that's what I'm asking. Like, I don't understand how you're supposed to know.
Well, we know not to use that one because we want to write it in terms of sine and cosine, and we weren't able to do that. So
See, like, on the test, you're going to tell us it's what you want.
I'm telling you right now, I'm trying to teach this to you, and I'm telling you to write it in terms of sine and cosine. And I'm telling you that's not going to work. Sometimes it's trial and error. We tried that. It was an error. So now we're going to write it in terms of sine and cosine. So on number 5, this cosine is already there. We need to rewrite tangent of theta in terms of sine and cosine. If we rewrote this as the cosine of theta times 1 over the cotangent of theta, that is not in terms of sine and cosine. It's not going to work. Let's try a quotient identity instead. So let's rewrite this as the tangent of theta as what? The sine of theta over the cosine of theta. From here, what can we do with these cosines of thetas? Cross them out, and we're left with just the sine of theta. Okay, hold on 1 second.
I think
Murphy.
it's such a really completely different one.
Did you still get the sine of theta?
Nope.
Okay. Remember, I don't know how else to say this, and I don't know how many times I have to say this, but you want to write these in terms of sine and cosine, okay?
I actually did both instead of picking one.
Okay. Yes, ma'am.
Can you do a problem where you use reciprocal
The next problem we're going to do is, we never finished number 6, so let's finish number 6. On number 6, how can we rewrite tangent? How can we rewrite tangent? The sine of theta over the cosine of theta. And how can we rewrite the cosecant of theta? How can we rewrite the cosecant of theta? 1 over the sine of theta. Okay? So we can cancel out sines of theta, but not the cosine, can we? So this gives us 1 over the cosine squared of theta. All right, and what is 1 over cosine squared of theta equal to? What is 1 over cosine equal to? Secant. So this would be secant squared of theta. Because there's 2 cosines, so there's 2 secants. Any questions here? Yes, ma'am. Sure. Okay, what'd you get as your answer? Have you done it?
I tried to do it.
Okay, number 10 is not nearly as bad as you see, and you'll see that shortly. On number 10, how do we rewrite the secant of theta? 1 over cosine of theta times cosine squared of theta. So this is just cosine squared of theta over cosine of theta, which means you've got 2 cosines in the top, 1 in the bottom, which means you can cancel out one of them, and this is just cosine of theta. That's your answer.
Thank you.
Okay, number 11 is one of those that we should be able to look at and obviously identify as what? A Pythagorean identity. Very good. Okay. Let's go ahead and flip over on the back. Let's look at number 27. All right, 27 on the back. Should I rewrite cosine as anything or not? No, it's just the cosine of theta, right? Now, how do I rewrite cosecant?
1 over sine of theta.
Right, so this is times 1 over the sine of theta. And what about cotangent?
1 over tan. Oh, wait. Cosine over sine.
Okay, so I'll multiply this through, and that's going to give us cosine of theta over sine of theta divided by what? Cosine of theta over sine of theta. And remember, when we divide by a fraction, it's the same as multiplying by the reciprocal. So this is just the cosine of theta divided by the sine of theta times the reciprocal, which is sine of theta divided by cosine of theta. These cancel, and we're just left with 1. On number 24, there was an error. That should be 1 plus the tangent squared of theta. On number 24, make that 1 plus the tangent squared of theta. Look right here, 24, 1 plus the tangent squared of theta. On number 24, please make sure that that is 1 plus the tangent squared of theta. Okay, let's look at number 20. Number 20 is actually, it looks crazy, but it's actually really easy and requires almost no work. What is the sine squared of theta plus the cosine squared of theta?
1.
So now we're left with 1 plus the tangent squared of theta, and what is that? Secant squared of theta. Please raise your hand if you feel better about this. Please raise your hand if you have a question about a specific problem that you would like to see worked out. Yes? Yeah?
7.
I will do 7, but you're going to be like, oh my gosh, yeah, okay, you'll see. Okay, on 7, this is the sine of theta divided by what, Griffin? 1 over sine of theta. And this is the cosine of theta divided by what, Griffin? 1 over cosine of theta. So we have the sine of theta times, what's the reciprocal of 1 over sine of theta? So it's sine of theta times sine of theta, because it's not 1 over sine of theta, but the reciprocal of that, which is sine of theta over 1, plus cosine of theta. And what's the reciprocal of 1 over the cosine of theta, Griffin? Cosine of theta over 1. Are you now seeing what's happening here? So that gives us sine squared of theta plus cosine squared of theta, which we should know in our sleep is 1. Any questions? Sierra, how are you feeling? Okay? Alvin, do you feel better? I know you were a little worried about this yesterday, but are you feeling better today?
So you would change them and multiply it by a reciprocal.
Right.
And then
Right.
start solving.
Well, we're not really solving, we're simplifying. Remember? So there's no equal sign, we're just simplifying.
No, okay.
Okay? All right.
Yeah, I see it.
All right, good. Yes, Murphy.
Go over 8 really quick,
8 is one of the Pythagorean identities. That's my hint for you for 8, okay? I would like to go over let's go over number 17 on the back. Okay, on number 17, this is just cosine of theta plus sine of theta. Now, how do we rewrite tangent of theta?
1 over is tan. Oh, wait, no, sine.
H. Cosine of theta plus sine of theta is just
I've
Okay, I got it. Never mind.
if yours,
Nope.
I know, but there are some people who might not know. I don't know if you guys. Sometimes I get that I say things and you're zoned out, and that's fine because people say things and I zone out. I'm not judging you for that, but I want to make it very, very clear that we want to write everything in terms of what, Samuel?
Sine and cosine.
Sine and cosine, okay? So again, I'm not mad. You tell me things and I don't listen sometimes because I'm distracted. So just from now on, that's why we left sine and cosine alone, okay? So now this is going to give us cosine of theta plus sine squared of theta divided by cosine of theta, okay? Now, we look at this. What are you thinking?
It's going to cross. It's going to cancel out cosine of theta.
Well, we can't do that because we're adding, not multiplying.
Make the common denominator.
Common denominator, very good. Okay, so in order to do that, we need to multiply the top and bottom by what?
Cosine.
Cosine, right? Do you see why it's cosine, Sam? And that gives us cosine squared of theta plus, can I go ahead and combine them? Does that confuse you? I just went ahead and put them together. Is that okay? Are you sure you're okay with that? We were going to do it anyways, right? Yes, Alvin.
Kind of wondered, like, even if we don't use the formula cotangent equal to 1 over the tangent,
Mhm.
why is it still there? I'm just curious.
Alvin, can I answer that question a little bit after I finish this problem? Okay, thank you. This is going to give us 1 over the cosine of theta, right? Which is equal to the secant of theta. Okay? All right. Your homework is going to be to finish the front and back of the first and the second sheet that I gave you. So that's day 1 and day 2. You only have to finish the front of each, though.